I'm going to talk about the signals and stochastic processing. The subheading is basic operation of signals. This is lecture number 3. Basic operation of signal is several manipulation is represented as several manipulation involved in the independent variable or the amplitude of the signal. It's categorized for the 6. One is time shifting, time reversal, time scaling, amplitude scaling, signal addition, signal multiplication. We'll see one by one of basic operation in signals, both continuous time signal as well as a discrete time signal. First one is a time shifting. Time shifting is represented as a shifting of the entire signal along the time axis. The signal result in time delay or time advance. If time delay, the signal is represented as a y of t is equal to x of t minus of t. If go for the advance, the signal is represented as a y of t is equal to x of t plus of t. For in this case of discrete time signal, how we may represent for the time shifting. The time shifting operation discrete time signal is represented as a y of n, x of n minus of k. This is also possible to have for the time delay or time advance. For example, you take here, this is a continuous time signal. So we represent for the x of t. Here I taken for the one signal, it started for the 0 to 6 only. The amplitude is represented as a. Then I use for the x of t minus of capital letter T. This capital letter T is represented as a shifting the time. So now the resultant output is started for the T. Instead of 0 of x of t is started for the capital letter T. Then same signal is going to happen up to t plus of 6. So this is represented as a signal of time delay. So how many time delay is going to happen? X of t plus of 6. Next, if we go for the advance, I represent for the x of t plus of capital letter T. So how much t is going to happen? While here I write for x of t plus t. This is represent taken for the origin. That means the time interval only we taken for the origin. T plus of capital letter T is equal to 0. Then t it started for minus of t. That's why I measure for here as a minus of t. Then here the left side, left side is minus of t, right side is represent for the minus t plus of 6. How much time duration is going to delayed? That much time duration is making to add for your right side. This is represented as a time advance as well as a time delay of continuous time signal. Next, you take for the example of discrete time signal, how the time delay as well as time shifting is happen. Here I taken for the x of n for 0 it's represent for the 1 as a discrete values. Then 2 that is represented as a 1 is represented as a amplitude of 2. Then 2 discrete interval amplitude of 3. Then 3 discrete interval of amplitude of 2. Then 4 is represented as amplitude of 1. 5 that is a represented as a 0. So this signal is going to shifted for the x of n minus of 3. So this means what will be happen? N minus of 3 equal to 0. Then n equal to 3. So third 0 is going to shifted for the third position. See, so 0 here is 0. It's shifted for the our resultant signal as a third position. So that 0 is what they're going to have 1. Then 0 plus 1 that is a 3 plus 1 is 4 is represents a 1 position of discrete value shifted for the fourth position. Like this way it will be going to shifted. At end of the case, what will be happen? The seventh one and the fourth one are similar. This means the signal of discrete time signal, the signal of discrete time signal shifted for the n minus of 1, n minus of 3. At the same time, I take for the another example of advance. So what will be represent? So here I take example of x of n plus of 2. So this n plus 2 equal to 0, then n equal to minus of 2. So what will happen? The zeroth position, the 0th position is going to shifted for the minus 2 position. See here, 0th position is shifted for minus 2th position. Then first one it's going to shifted for the another position, that is minus 1. Then second position is going to shifted for the 0th position. Minus 2 position is going to shifted for the advance. So this is represented as a time shifting operation of continuous time as well as of discrete time signal. So generally we call for the y of t as a continuous time signal. Continuous time signal. Y of t is equal to x of t minus of capital letter T. T is represented as an independent variable, or sometimes we call for the constant. So if you take for the discrete time signal, the time shifting is represented as a y of n is equal to x of n minus of k. Here k is represented as an independent variable. This is we call for the time shifting operation of both continuous as well as of discrete time signal. Next, we go for the time reversal. Next operation we represent as a time reversal. What the time reversal is represent? The time reversal of the signal is folding of a signal about the vertical axis. It is simply taking a mirror image of signal about the vertical axis. The time reversal of continuous time signal can be represented as x of t is equal to x of minus t. So the time period only going to reversed. So here is plus, here I reversed for the minus. That's it. This is we call for the time reversal or folding of signal. That means what the left side of our signal, the coordinate of left side is going to shift for the right side, or right side is going to shift for the left side. For here I take for the continuous time signal. For example, I take for the continuous time signal. So this one is represented as x of t. The 0 is 0, 1 is some constant. It's getting for the ramp signal. After that it is represent the constant. Then again it's reducing, exponentially reducing up to 4. This signal I represent for the x of t. What is the meaning of x of minus t? So this x of minus t, in the sense 0 is going to present for the 0th position only. This entire thing is going to shift for the negative direction, positive direction of your x of t into negative direction. See, this is a resultant image. So 0 is going to have the 0. This value will be shifted for that based on the time period shifted for the right to left side. This is represented as x of minus t. At the same time, time reversal also is possible to for the time shifting. Here this is x of t. I am going to shift it for the plus 3 position. Plus 3 position of x of t. So how it will be going to make? See, x of t I made for the time reversal as x of minus t. This x of minus t plus of 3 position I make to shift it. So x of minus t plus 3, how this value I should write as a minus t plus of 3 equal to 0, then minus t equal to minus of 3, t equal to 3. See, the 3 position I am going to shifting. So see here, the minus 4 is there, that is x of minus t, minus 4 is there. I shifted for the 3 position. There is 1, 2, 0, 1, 2. This is the 3rd position. See, the signal is going to shift for the minus 3 to plus minus 1. Minus 4 to minus 1. So now what will be happen for the signal is getting for the time advance. The discrete timer, after making for the time reversal, I done for the continuous time advance. So this minus 4 is shift for minus 1, the 3 is shift for the 0, 2 is shift for the 1, and minus 2 is to shift for the 1, plus 1 is minus 1 is shift for the plus 2, then 0 is shift for the 3. Same signal will be going to happen for here, but only time getting to change. And even we do for the delay also, time delay. After doing for the time shift, we do for the time delay. Here I take for the x of t as a this signal. This is original signal. Is I converted for the x of minus t as a time reversal. We got it this one. Then after we do for the time shifting, that is x of minus t minus of 3 position I am trying to shift. So that means minus t minus 3 equal to 0, minus t equal to 3, then t equal to minus of 3. So now what will be happen? This 0th position is shifted for the minus 3, then you substitute for the value, then it's going to shift. The signal will be moved from the left side only, minus 4, minus 5, minus 6, minus 8. This is the way we do for the time reversal as well as we do for the time shifting also, both our time advance as well as time delay. Next is I should take for the discrete time signal, that is x of n. I represent for the x of n of discrete time signal. Now this is a x of n. So the 0th position amplitude is represented as a 4 in the discrete values. Then first position, that is a discrete value of first position, amplitude is equal to 3. 2 is represented as a amplitude 2. 3 is represented as a amplitude 3 of discrete interval. 4 and 5 is represented as a zeros. I take this example of time reversal case. Now I want converted for the x of n into x of minus n. So what will be happen? It's represented as a time folding. That is left side is converted for the right side, or right side is converted for the left side, is represented as a time folding. Now if we go for x of n is equal to x of minus n, then what will happen? So this is it will be 0 is present for the same position only. There is no problem. Next, if we substitute for the n equal to 1, what will be happen here? N equal to minus 1. Here is 1, here is minus 1. So this 1 value is go for the left side. That what the amplitude 3. This 3 is going to here. So next you substitute for the n equal to 2. That is here is n of shifted, that is folded values x of minus n equal to minus 2. So 2 is shifted for here. What the 2 of here is shifted by the minus 2 position. Then 3 is shifted for the minus 3 position. 4 is shifted for. Now what will be happen here? Time is getting to folded for discrete time continuous discrete time signal. Next, I should go for the advance as well as of delay. So here the signal is possible to already be seen for the continuous time signal. The signal is possible to do for the folding operation also. That means time delay or advance, the time shifting operation. So the discrete time signal here, x of n we know, x of minus n we know as a discrete time reversal. Then now I will go for the x of minus n plus of 3. So what will be happen? Minus n plus 3 equal to 0. It's going to start at for the origin as 0. Then minus n equal to minus of 3, n equal to 3. So now you represent for the n equal to 0. That 0 position, it's go for the plus 3 position. So this 0 position, this is x of n, this is x of minus n. Then after we do for the time shifting operation, x of minus n plus of 3. Then this 0 position, it's go for the third position. So see the 0 position, it's go for the third position. What the 0 amplitude? 4. Next, n equal to 1. That means what will be happen? Here is n equal to 1. So here n equal to 1. So here is 3 plus of 1, fourth position. N equal to 2. This is 3 plus 2. This represents a fifth position. What the fifth position? So what the fifth position? That is a 2 value. Let's go for the fifth value. Next, we go for the n equal to minus of 1. That is equal to 3 minus of 1 equal to 2. For the 2 position, it's going to happen, that is n equal to minus 1. The x of n minus 1 minus 1, this position it's go for the second position of our resultant value. What the amplitude? 3 is at 3. Then next n equal to minus of 2. So here 3 minus of 2 is equal to represent as a 1. So the minus 2 position it's go for the plus 1 position. Next n equal to minus of 3. This is represent as a 3 minus of 3 equal to 0. The 0 position is came. Same like that one be going to happen for the all the signal. This is we call for the time shifting operation of x of n minus 1 with plus 3 is a discrete case. Next we go for the minus 3 operation, that is represent as a x of minus n minus of 3, that is delayed version. So discrete time delayed version. See here we know x of minus n is represented as a x of n we taken from the discrete time signal, we converted for the time reversal of x of minus n, and then after we go for the x of minus n minus of 3. So minus n minus of 3, this value started for the 0 in the position. Now minus n equal to 3, then n equal to minus of 3 we represent. So now I should represent for the n equal to 0. So this is represented as 0, that means minus 3 plus of 0 is going to happen. So what will be happen? This 0 is shifted for the minus 3 position as per the statement of time shifting. So next case, what will be happen? Minus 3, this is 0 is a 4 as a amplitude of discrete time signal. Then this minus 3 is represented for the amplitude of 4. Then n equal to 1 minus 3, this value is represented minus 3 plus 1 is equal to minus of 2. This 1 is going to shifted for the minus 2 position. What the plus 1 is going to 0. That 0 is going to shift for the minus 2 position. Next we go for the another one for n equal to minus 1. Now I take for the n equal to minus of 1. We represent this value is go for the minus of 3. Minus 1 in the sense what will be happen? Minus 3 minus of 1 is represent for the minus of 4. So minus 1th position it's going to shifted for the minus 4th position of the amplitude. Now n equal to minus of 2. Then minus 3 minus of 2 is represented as a minus 5. So minus 5 it's going to shifted for the x of n minus 3, the result value shifted for the x of n minus 1 as a 2 amplitude. So this is the way we can shift for the all the signal like this one is shifted. So it's going to happen for the advance as well as of delay, both is going to satisfy for the time reversal function or time folding function. So this is common for both continuous as well as a discrete time signal. Next operation for the signal, for here I will take for some example, sketch the following signal. Here I will take for u of t, u of minus t plus 2. Then another signal is d equal to 2 u of minus 2 u of t plus 2, c minus 4 r of t, and d 2 r t minus of 2. Then I will go one by one. First you take for the a. A is represented as u of minus t plus 2. First we need to find u of t. We know the definition. U of t is equal to 1 when t is greater than 0, 0 t less than 0, t is greater than or equal to 0 for 1, 0 t is less than 0. Now we should write first this waveform. So u of t is represented as 1 when it starts at 0 here. So up to 0 is 1, Then after 0 of minus side of all values represent 0, the plus side is represented as a 1. This is u of t. Now we should write for the u of t into u of minus t. That is a time folding. U of t into u of minus t. That is called for the time folding or time reversal. So what will be happen? It will be happen when the right side values are going to shifted for the left side. So what the right side is going to happen? The positive, all positive of your t in the coordinate, it's represented as a 1. This is going to shifted for here. See, for the waveform here, u of minus t is represented as a 0 is 0, the amplitude is 1. What the positive side of your coordinate in t, that will be shifted of negative side. This is we represent for the u of t minus t in the continuous time signal. Then after this operation is over, u of minus t we over. Next we advance for the 2, u of t plus 2. Now you know we know for the u of minus t, then u of minus t is equal to this value. It started origin is 0. So now we take for the minus t plus 2. It started origin is here. I assume to here. Then 0. Minus t is equal to minus of 2. T is equal to 2. Now the initial value 0. It started for 2. So it started 0. Then what we do? Then you substitute for the t equal to 0. This is equal to 2. T equal to 0. The resultant value is represented 0. So now this 0 is going to shifted for the 2. This 0 is going to shifted for the 2. Next, for example, I taken for the 1. This is 2 as this is here only other signal. Here I take for the minus 1. That is 2 minus of 1 is equal to 1. See, the 1 is represented as same amplitude. What will be going to shift at? Like that one I do for all the signals, for all the coordinate value. And the resultant value is going to shift at for 2 to 0 to 1, 0. All it will be represented for the 1 of your amplitude. So this side, for the positive side, after 2 is represented as 0. So here there is no signal. That's why it represents as 0. This is a way we may represent for the signal operation for time shifting. In time shifting, the case of u of minus t plus 2. Next case, b minus 2 u t plus of 2. First, what we do for the b sum, we do for the u of t first. U of t we need to find this value equal to 1 when t is greater than or equal to 0, 0, t is less than 0. So first we draw for this one. So this is u of t we taken for this signal, continuous time signal. We write for the drawing of u of t, this one. Next, after that one, we need to do for the operation of time shifting. So second operation is time shifting t plus 2. U of t we do converted for the u of t plus of 2. So what will happen? T plus 2 equal to 0. Then t is going to start at for minus 2. See here, this one is going to make to do for the time shifting operation of minus 2. This one, it's that 0 is go for the minus 2 here. Then after it's represented as the right side only is going to have the signals. So this side will be represented as 0. Next, we need to do for the scaled values. Scale of your signal minus of 2. So this is u of 2. So u of t is represented as a 1. Then 2 time of u of t we represent as a 2 time of t. 2 into 1 is equal to 2. So here is represented as a minus. Then this is also minus. That means what will be happen? The signal here is the signal 2 is going to start at based on our time shifting operation for t plus 2. This is the case. Then when you apply for the multiply with the minus 2, then the signal is go for downside of your x value. Here is a 2. Then after the signal is going to getting to continue for together for 1, 2, 3. This is the output signal of minus 2 u of t plus 2 is represent. Next we go for the exponential signal that we know that is r of t is represented as a ramp signal. That next example, that is r of t is represented as a ramp signal. The r of t is equal to t. When t equal to 0, 1, 2, 3 like that one we increase, then what the signal is happen, and the signal is go for increasing for the 45 dB. This is 0, 1, 2, 3. Then this is 1 in the sense 1, 2 in the sense 2, 3 in the sense. This is a continuous signal. We join for all points, we get for the straight line. Now this is represented as r of t. Now we go for the r of t into minus 4 r of t. So what will be happen? We need to multiply for the 4 times. At the same time, it's represented as minus direction. Now we write for the r of t as like this form. Then after substitute t equal to 0, r of t is equal to 1, r of t equal to 0, t equal to 1, r of t is equal to 1. Then you represent by minus of 0, 0, that is a minus of 4 into 0. Next, this one is minus of 4 into 1 is represented as a minus 4. So like that one you substitute for the t equal to 2, t equal to 3, t equal to 4. The values are you are getting for minus 8 and 3 in the sense 3 into 4 minus 12. Then t is equal to 0, 1, 2, 3. Because we know r of t is represented as a t when t is greater than 0, greater than or equal to 0. 0 otherwise. This is represented as a ramp signal. Then we substitute the 0 equal to 0. Then we to take for the 1. T equal to 1 is represented as a minus of 4 here. Like that will be going. Then finally you join for all the points, we get for the negative side of your ramp signal. This is represented as a minus 4 r of t. Next case we go for the time scaling operation of signal. What the meaning of time scaling? The time scaling is compression or expansion of the signal on its axis in the time axis. So we may write the mathematical function as y of n is equal to a x of n. In this case, a is represented as a constant. Based on that a, the signal is getting to vary. When a is greater than 1, it is time compression. And when a is less than 1, it's represented as a time expansion. We'll see the example of both time compression as well as expansion. Here, I take for some example. The a equal to 2. I take for same equation, a equal to 2. Then I rewrite the equation as time scaling operation. Y of n is equal to x of 2n. Now, our signal is represented as a y of n equal to x of 2n. Now, we need to substitute n equal to 0, n equal to 1, n equal to 2. Here I take for here n equal to 0. That is represented as a y of 0. The y of 0 is equal to x of 0. So, because of 2 into 0. So, if you need to find for this value, I take some example. For the example, here I take this one is represented as a x of n. I represent for the x of n. X of n minus 3 is represented as a plus 4 of amplitude. The time interval minus 2 is represented as a plus 3. Minus 1 is represented as a 2. The time interval 0 is represented as a 1. That is origin. Next discrete interval 1 is represented as a 2. 2 is represented as amplitude is 3. 3 is represented as amplitude 4. Then now you should substitute n equal to 0. That is 2 into 0 is represented as x of 0. This position 0 is represented as 0. So now resultant value I should write for here. So 0, what the amplitude is present 1. I should write for 1. Next, I should substitute for the n equal to 1. So, the y of 1 equal to, what is that? X of 2 into 1. What is the 2 into 1? X of 2. So, while come to the 2, the x of 2 is going to display. So, if the n equal to 1, the output is, this is y of n, is represented as x of 2n. So, when n equal to 1, the input is represented as x of 2. What the x of 2 is that the amplitude is 3. See, here I mentioned for the amplitude is represented as 3. Next, you take for the n equal to 2, then y of 2 is represented as x of 2 into 2 is x of 4. So, what the x of 4 is at 0. So, the 2th position of your discrete value of your output of y of n, they represent as a 0. 0. Here also 0. This is also the input is 0. That's why output also 0. Next, I should apply for the n equal to negative values. So, here the signal, input signal they given for the negative value also. Now, y of minus 1, n equal to minus of 1 is equal to x of 2 into minus 1. 2 into minus 1 equal to x of minus 2. See what the x of minus 2 values are there, then is represented as a 1. X of minus 1 in the negative direction. Left side in the output signal. Next, n equal to 2. Y of minus 2 is equal to x of 2 into minus of 2 is represented as x of minus 4. What the x of minus 4 is at 0, 0. So, what is its meaning for here? When a is greater than value of 1, the time compression is going to happen. Compare with this two. This is the input, this is the output signal. So, what will be happen here? It's present for the minus 4 to plus 4 is there, but it will be happen for the minus 2 to plus 2 in the output signal. So, the signal is getting to compressed. If you take for a is equal to lesser than value, time it's represented as increased. This is represented as a plot the time scaled signal y of n equal to x of 2n. Here the signal is getting to compress with by 2. So for here, see this 0 is here also 0. It's take for the 2. It's present for the y of n as a first position. So this signal is going to sink. The signal will be going to synced. So that's why it's represented as a compression. If you do for the time scaling operation, it's happen for the two kind of signal. One is compressed signal or exponential signal. This will be used for while we are doing for the image processing. Otherwise, if you are going to reduce a signal strength, that time we may use for the time scaling operation in the electronic circuits. So here I take for the one more example. When a is lesser than of 1. See here, a lesser than of 1 in the sense a is equal to 1 by 2. This represents as 0.5. So here I take for the a equal to 1 by 2. So now y of n is represented as a x of n by 2. X of n by 2. So same what we are going to discussing the previous input, same that input here I taken x of n. Minus 3 interval, discrete interval, the amplitude is equal to 4. Minus 2 interval, amplitude is equal to 3. Minus 1 interval, 2. 0 interval, 1. 1, 2. 2 amplitude is equal to 3. 3 amplitude is equal to 4 now. See, here the output, how may represent? See, so now y of n, I should take is equal to x of n by 2. See, now what will be happen? You substitute n equal to 0. What is that? Here this value n equal to 0. So here is represented as x of n is represented as 0 divided by 2 is equal to x of 0 only. 0 divided by 2, 0. What is there in the 0? That will be here I may write. Next, I should write n equal to 1. N equal to 1. What is represent? X of this value y of 1 is represented as y of 1 is represented as x of 1 by 2. So this is x of 0.55. See, 1 by 2 is represented as 0.5. That's why there is no signal. There is no signal for here. So that's why we represent for the 0. So next, n equal to 2 is represented as x of, this is y of n equal to, y of 2 is equal to y of 2 is equal to x of n by 2, that is 2 by 2. What is that? X of 1. Now, if we represent 2, the x of 1 value is going to shift. For here, x of 1 is equal to, amplitude is equal to 2, then here it's represent shifted. So same like that one, I will do for all the signal. It's compared with the input as well as the output. What is that? The input is present for the -4 to +4, but it's going to expand for the -7 to +7. Like that one be going to happen. That means when a is lesser than of 1, when this is represented as an expansion, when a greater than or equal to 1, then that is represented as a compressed. So our signal y of n is depends upon the x of x of n depends upon the y of n is depends upon this constant. So this is represented as a time scaling function of continuous as well as of discrete time signal. Next, amplitude scaling. Amplitude scaling of discrete time signal can be represented as y of n equal to a x of n. A is represented as a constant. If a is greater than 1, amplitudes are increased. If a is less than 1, amplitudes are getting to decrease. That's why we call for the attenuation when a is less than 1. For take example, here I take for the example of x of n, that is -1 to +1, and the -1 amplitude is equal to 2, 0 is amplitude is equal to 1, 1 is amplitude equal to 2. I take for the discrete time signal. Okay, that's why I represent for the x of n. Next, now I take a value is equal to 2. That means it's going to satisfy for the amplification. Then y of n is equal to 2 time of x of n. 2 time I am going to increasing for the a or x of n. So now I substitute n equal to 0. Here is 0, the amplitude is equal to 1. Then y of 1 is equal to 2 time of x of 0. So this is 2 into, what is the x of 0 amplitude is equal to 1. So this represents say 2. This is 0. Y of 0 is equal to 2 into x of 0. It's represent for the 2. The 0th position amplitudes are increasing for 2. Next, we take for the n equal to 1. So how to represent for this one? N equal to 1. Y of 1 is equal to 2 into x of 1. What the x of 1 is present? It's represented as 2. The 2 into 2 is represented as 4. Now y of 1 is represented as 4 amplitudes. 4 amplitudes is represent. Next, we take for the another one is -1. Y of -1 is equal to 2 into x of -1. What the -1 amplitude of x of n is represents 2. Same 2. Then it's represented as 4. Then -1th position, what will be going to happen? We represent for the +4 of a signal. So now what will be, you compare with the input as well as of output while doing for the scaled value of 2. The signal is getting to amplified because of our discrete value amplitudes are increasing, but there is no time changes. But in this case of time scaling, this is amplitude time scaling. What will be going to happen? The time scaled value based on the a, it's compressed or expand. But time scaling value, amplitude scaling value, the amplitudes are getting to scale for input as well as output. Both it depends upon the A, that is constant value only for both continuous as well as discrete time signal. Next, we go for the addition of signals. The discrete time domain, the sum of two signal x1 of n and x2 of n can be obtained by adding the corresponding sample values. So that means if you need for the y of n, here I take for the discrete time signal. For example, here I write for y of n equal to x1 of n with addition of x2 of n. So the x1 of n plus addition of x2 of n in the sense what the amplitude is present for the x1 of n into n position, that will be added with the x2 of n. This is called for the addition. That means summing of two signal x1 and x2, x1 of t or x2 of t. So both it's possible for the continuous time as well as a discrete time signal. Now we go for the example based on the addition of signal. Even the addition of signal, it's also possible to satisfy for the subtraction of signal. How to represent here I have taken for the example of discrete time signal. Y of n is equal to subtraction with x2 of n minus of x1 of n. This means what the nth discrete order, it subtract with the nth discrete order only. So both is possible for the signal addition as well as subtraction in both the continuous as well as discrete time signal. Now here I take for the discrete time signal, for example, discrete time signal. Here I take for x1 of n is equal to 1, 2, 3, 1, 5 and the x2 of n is equal to 2, 3, 4, 1, 2. Now I write for the addition. What is that? Y of n, I should write equal to x1 of n plus x2 of n. So now in this case, first I take for n equal to 0. This means x1 of 0 plus x2 of 0. Now I give for the index value of 0, 1, 2, 3, 4. For x2 of index value is equal to 0, 1, 2, 3, 4. Now what is there? What are we doing now? Y of n equal to 0. Then y of 0 is equal to x1 of 0 plus x2 of 0. That means what the x1 of 0 is represented as a 1. See, x1 of 0. x2 of 0 is equal to 2. Then 3. Now y0 is equal to 3. That means I should write like this one. So the 0th position 3. Next I take for 1. This is x1 of 1, x2 of 1. So what the 1 value? 2. The 1 value is 2. Here is 3. This is 2. This is 3. Is represented as a 5. I should write 5. So this is I should write for here like this one. x1 of n plus x2 of n. So first one is a 0th position. 0 plus 0. That is x1 of 0 plus x2 of 0. 1 plus 2. Next I write for the second position. That is represented as a 1, x1 of 1, x2 of 1. I write for 2 comma 2 plus 3. Next third position. That is 2. 3 plus 4. 3 plus 4. Next 1 plus 1. Next 5 plus minus 2. This is 1 plus 3 is equal to 3. Then 2 plus 3 is equal to 5. Then 7. Then it will be other 2. Then 3. Now this is represented as a y of n. Now y of n is equal to 5, 3, 5, 7, 2, 3. We may write. This is called for the addition of the signal. Next, we go for the subtraction. Same like that we do for the each and every discrete interval. Now here I write for the x1 of n minus x2 of n. The first place is represented as a what that here is 0th position is 1. For here is 2. That means 1 minus of 2. Next is 2 minus of 3. 2 minus of 3. Next 3 minus 4. Next 1 minus of 1. Next 5 minus of plus, here is minus is a minus plus. Then I will subtract for 1 minus 2 equal to minus 1, 2 minus 3 is equal to minus 1, 3 minus 4 equal to minus 1, 1 minus 1 equal to 0, then 5 plus 2 equal to 7. This is represented as y of n. This is the way we are making to do for the addition as well as subtraction. Addition and subtraction, it's going to happen only the time interval only. Next we go for the signal multiplication. So the signal multiplication of two discrete time signal can be performed by multiplication of their value at sampling instant only. That means sampling instant in the sense that the time interval only. For example, I take for the discrete time signal x1 of n is equal to 1 minus 3 2 4 1 1.5 and x2 of n is equal to 2 minus 1 3 1.5 2. Now the statement said, the signals multiplication statement said, the multiplying the value at sampling instant. What is it? 0 is multiplied. This is index value 0 1 2 3 4. The x2 index value is 0 1 2 3 4 4. So 4 values are there. The third value is represents 1.5. So now it's their value of sampling instant. So 0 is multiplied with x2 of 0, x1 of 0, index values multiplied with x2 0 index values. That means 1 into 2. I write here minus 3 into minus 1. Next 4 into 1.5. Next 1.5 into 2. So now 1 into 2 equal to 2, minus 1 plus minus 3 into 1 3, then 2 into 3 6, then 4 into 1.5 equal to 6, then 1.5 into 2 equal to 3. This is represented as a y of n. That means if you multiply for the signal x1 of n as well as of x2 of n, that will be happen only multiplying their value at sample instant. That means the discrete instant only. This is called for the signal multiplication. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.